thanks again for coming on today. Really excited.
Yeah, definitely. I'm excited to chat with you guys this morning. All right. Let's do this in the correct order. All right. Do you have the correct screen?
Sure do.
Yeah.
Okay.
Cloud.
All right. A lot of this is pretty similar to what you guys saw at the Eddy Symposium, so I apologize for that. Let's see, turn.
For what it's worth, I'm not sure if a bunch of the people here were actually at it. So
Yeah.
I was not at it, so I'm looking forward to this.
Okay. All
I
right.
saw something at the AGU, but I saw a lot of stuff at the AGU, so it's good to focus on it here.
This will be actually pretty different. Well, some of it will be similar, but most of it is pretty different than what we did at AGU because we didn't have much time. But yeah, so thanks for having me. I'm excited to chat with you guys about, a lot of the overlap that we have. Before I get started on this is, obviously a team effort, like you guys are full aware. So I have a lot of collaborators on this, and our funding agencies have been really incredible at, kind of deciding to invest in us, I think in the same way that you guys are funded through NASA unsolicited. So yeah, this was kind of cool to work with the program officers and kind of just spin up this idea and for them to kind of support that. Even though it was, a little bit high risk. So yeah, I'll be talking to you about CrowdCloud and some of the community building that we've been doing in our infrastructure. And I'm sure you guys are aware, this open science revolution that's happening with NASA, and how, cloud computing is, kind of the way of the future. It's changing the realm of possible questions that we can ask in science, and it allows us to advance science and inclusivity simultaneously. This paper was written by Shel Gentleman, who I'm sure y'all are aware of her. And so cloud computing kind of allows us to democratize science, for example, allowing us to access large amounts of compute, no matter what kind of computer we have, as long as we have a little bit of internet. So a Raspberry Pi in this tweet. I'm waking up still, clearly. And then being able to access this from our cell phone or on a flight. So it's kind of the way of the future. And new organizational models are needed to be able to access the cloud. And that's where CrowdCloud kind of comes in. So we were born out of the ISAT2 science team. We had a meeting I guess it's not last year now, in 2022 in May, where a science team for ISAT2, which is a laser altimeter for NASA. They got together, had a cloud computing panel and an open science panel, and they kind of discussed the fact that cloud computing was really challenging. There were non-intuitive pricing structures, infrastructure, and computing options. Documentation was poor. It was costly to use, so a lot of our users who had tried building their own platforms had, rung up thousands of dollars without getting much done because of the setup that they had built. And it wasn't obviously more collaborative or faster for some people. And Joanna Milstein and she's now a postdoc at School of Mines. We were sitting in the crowd and we'd used the cloud, and these issues that people were bringing up were not really ringing true to our experience in working in the cloud. And that a lot of the reason for that is because we'd been using infrastructure that was built by 2I2C, who I'm sure you all are aware of, the International Interactive Computing Collaboration. And 2I2C is a nonprofit service provider for Jupyter Hubs, basically interactive computing infrastructure. And for anyone not aware, they are they kind of were born out of this collaboration between people at UBC, Pangeo, and Berkeley, who had all built Jupyter hubs separately, and they had been catastrophically successful. More people wanted them, and they weren't able through their institutions to provide these as a service, so they built 2I2C instead. And so 2I2C has this kind of mission of science and education committed to building, you know, our ability to access the cloud in as cheap of a format and effective of a format as we can make it. And so they build these platforms, and all of the infrastructure and progress that they made is contributed back to open source communities, similar to how y'all work with PyHC. And so we decided to partner with 2I2C to build a cloud computing platform with bumpers, and that's CryoCloud. So our goal was to build a simple and cost-effective managed cloud environment for training and transitioning users to cloud workflows, while also determining community best practices for working in the cloud together. And so this is building a cloud platform that's developed for cryosphere scientists by software professionals at 2I2C in order to process data faster, minimize downloading, and democratize science. And CryoCloud is meant to be a persistent environment for at least 3 years. Hopefully we'll prove our use, and we'll get funding beyond that. We have small servers for all of our users, with the option for users to bring their own cloud credits to access larger servers. And we're doing a bunch of new tool development, so personal cost monitoring tool, intra and intra-hub collaboration tools that will be added to the Jupyter ecosystem when we're done. And we're helping 2I2C, who's kind of a young, small nonprofit, to scale up through our community surveys, feedback, and guidance. And so what we end up having is this hub that has custom environments, online content, cloud infrastructure, and support and services. And for us, all you need to authenticate is a GitHub user ID and password. And people just need to be added to our GitHub organization, and they get access. So it's very simple, very fast to get added. All of our infrastructure is at cryointhecloud.com. There's our GitHub. We have a Slack, community office hours, training tutorials and resources. And we're doing a lot of community building. So bringing cryosphere communities into the fold to share in infrastructure ideation and construction. So trying to figure out what gaps there still are in the tools, and ways that we can kind of meld different projects in the cryosphere and kind of fill in the gaps to glue a lot of things together, and reduce a lot of the competition within our community and enhance collaboration. So we're kind of working together to improve things. So what I'll talk to you a little bit mostly about today are the advantages to the community platform, and I'm interested to get feedback from what you guys have learned in a lot of this as well. So for us, obviously, one of the things that we're interested in is how the cloud makes our work faster. So data read-ins are 1 to 2 orders of magnitude faster. And then on top of that, we're breaking down our workflows so that what used to take, potentially months of downloading and accessing and finding data now, takes a few lines of code, and it's orders of magnitude faster to kind of access data. On top of that, CryoCloud makes the cloud, like, it's easy to use and customizable. So it's using the same software on your local computer as it is in an HPC, as it is in the cloud. So it's easy to learn, and that makes it much more consumable for our users, and a lot easier to get people to come on board and to use it. So we offer, as I mentioned, small servers, but we have multiple Docker images available for MATLAB, R, and Python, and now we have the other option, which I think you guys were mentioning, where, well, right now you can just paste in tags for other Docker images, but soon you'll be able to build your own from a requirements.txt. And then we have node shared to reduce costs, and people can use portions of a node instead of the entire node. And then, as I mentioned, people can access larger computers. So for Hack Week that we just put on, we had a medium server everyone could access, and there's a GPU because it was a machine learning Hack Week. It was the GeoSmart one. And so those are also available. And we actually are bringing Slide Rule, which is another part of the ISAT2 science team, another group that is doing on-demand processing for NASA to process from lower level data products to higher level data products. They're going to be migrating into CryoCloud and using large servers that only they have access to. So that's another thing that we're adding to all of this. So we're building the logistical framework to be able to do these kinds of projects and serve people in different ways. So CrowdCloud also makes collaboration easier. So there's co-coding options now, and there's shared tools, and sharing data is really easy. On top of that, we have a lot of different kinds of users all in one place, and this helps to accelerate feedback and collaboration. So on the left here, I have a tutorial where we ingest data from ISAT2, from the laser altimeter, from MODIS and Landsat, and which all give, visible imagery, thermal imagery, that sort of thing. And then we are using tools to find and access and use that data from like X-Array. IcePix opens ISAT2 data. Slide Rule, as I mentioned, does the on-demand processing, and Earth Access is, I'm sure y'all are aware of. And because we have the developers for these tools all in CryoCloud, when our users have bugs that come up, or questions that they have, or capabilities that they don't already have, they can ask these questions really easily in our Slack channel to a lot of these developers. And those developers are in the same environment as our users, can immediately find the bugs, fix them, and we get, this accelerated feedback cycle where these tools get built for the people using them. And the scientists are actively involved in that, which is, as you guys are definitely super aware of, one of the most important things. And, we've been working in isolation in the past in building some of these tools and working with some of these tools. So this part is, one of the exciting things about open science and working in the cloud, that, these tools are going to be built more for, the users who really need that, rather than in isolation from them. So CrowdCloud helps to connect the developers and the users. On top of that, CrowdCloud helps to eliminate technology bottlenecks, right? So we all have these shared challenges, the kinds of code that we need to access data or find data. We now have that available on CrowdCloud so that no one has to reinvent the wheel or figure out how to access data. The code's already available there. And we're building our Jupyter book to provide more pathways for accessing data, and, building a shared environment. So especially for our new users, early careers, graduate students just getting into working with Python, they don't have to build their own environment. And this reduces the, week or two that people need to get online to be able to work, in Python or whatever environment they're using. So using our cloud platform really benefits early careers, underrepresented groups, people who are not at R1 institutions. because we're democratizing science, we're eliminating these bottlenecks and providing compute power for people who don't necessarily have access to, the high performance computing or whatever it is. So because we are eliminating these bottlenecks, especially early careers benefit from this. And it also brings, allows us to provide access to data and science, in places that might not historically had access. So, right, if we bring our Greenland partners into CryoCloud, as long as they have internet, right, they can now access data sets much more easily than they potentially could before. And there's a lot more impact in providing data to people who are more underrepresented and have historically not have had access to this. So that sort of science becomes a lot more impactful. Another benefit is that no software expertise is needed. So we are really pushing the idea of cloud computing being provided as a service, especially but hopefully by NASA and other funding agencies, because we're building this and no one else has to do it for themselves. Our researchers don't have to become software experts to be able to use the cloud. So for instance, we have provided the cloud or our platform for these 6 workshops throughout the last year. And this means that they can just rapidly get onto CryoCloud. They don't have to build their own. And on top of that, if any teams or whatever come together, say for a climate emergency or some need within the community where a team has to rapidly mobilize, we can provide that really easily, the cloud really easily for that team. They can be online and start working together immediately. So we recognize this as one of the huge benefits for our community. And what we ended up doing is, you see these 4 workshops at the bottom there. Those are groups that we weren't planning to support when we first set out to work to build CryoCloud. And they were like additional benefits that, we could support because we had CryoCloud already available. But what this ended up doing, we realized, is both benefiting CryoCloud and our community, saving our community time and money by building this infrastructure as a service. So as a case study, for the Q Greenland workshop, which is a QGIS software platform or integrated platform that is built by our community. It's actually NSF funded, so it's not even NASA. But we decided we were able to support one of their workshops, and they have people from all over the world, from Greenland, from Denmark, and Europe working in this workshop. And so for them to stand up their own hub for 1 month, it would cost them about $4,500 for just the hub itself, $75 in cloud credits. You have to have software experts or science experts to advise in, building the tools that scientists need for it, and then 2 to 4 weeks by a software expert to build and maintain that hub. And with CryoCloud available, you get rid of all of that except for the $75 in cloud credits and a few hours to a few days of work by the lead to make sure that all the software and infrastructure is where it needs to be. And what we end up building from all of this is, this shared resource model for our community where we share expertise and technology. And it really eliminates a ton of work hours and money that our community would have otherwise had to build to be able to work on this together. And on top of that, our lead for Q Greenland talked about how the fact that you start your users in the same place, you don't have to worry about personal computers all have different kinds of bugs and things like that. And then he was able to fix bugs in CryoCloud that we would not have otherwise had fixed, because now instead of having to spend several weeks in building this hub, he's able to spend that to that time to make CryoCloud a better place. And that as like the lead of CryoCloud has been one of the coolest parts of providing this to our community, is that now we have community buy-in. Now we have experts like Matt who are running our events, software experts who can, add these amazing tools that I'm not a software expert, or a software developer per se. So he can add cool things, bugs that can be fixed in all of the Jupyter hubs. So hopefully we can propagate that to all the other hubs. And adding tools that I wouldn't otherwise be able to add because I don't have enough time and I don't have enough expertise necessarily. So it was a huge benefit to actually just have these events in CryoCloud. Between the hack weeks and the workshops that were added, CryoCloud became much more innovated. And instead of everyone kind of building together or like in their own little silos in the same direction, a little bit across the board, everyone working on their same different projects, we were now all building kind of in a ladder in the same direction collaboratively instead of competing. And so we got a really cool cloud Jupyter hub out of that. And so kind of all together, these kinds of things help to accelerate science and make our work a lot easier. And now we kind of have a community where we have, I think, reached a critical mass to be able to keep this as a self-sustaining ecosystem. And I think that's really cool, is once you reach that level of having a lot of experts who can provide information and support for beginners and build out the infrastructure, and everyone starts to have buy-in, then you reach this critical mass. And I think Julie's mentioned that being the case for y'all's group as well. So with that, we kind of we have this technological innovation, right, that we're all building, but the social side of it ends up being almost more important than the technological innovation in the success that we see moving forward, right? How we work together and kind of collaborate and build together ends up being far more important. And so having active engagement from the scientific community and building, this new infrastructure, these new community models is extremely important. And it really all goes to the point that open science is a process and not a product, right? Where the technology we build is really cool right now, but the social part of it, getting people's buy-in, really working together and collaborating is the most important part that we still are, working on and figuring out. And I'd really love to hear more about how you guys are doing this. So with that, thank you. And let me know what questions you have.
Well, thank you very much for that. If no one else wants to jump in, I could ask so many questions about this.
I'm kind of like you, Sean. There's a lot of questions I have.
I think I'll start with more of a first one and then a comment to open it up. First of all, this is super exciting to hear about because you're sort of a lot further along the path to doing something that I've been dreaming about doing for PyHC for a while, which is actually, you heard me talking about it just briefly before you started your talk, which is that I've been building just a Python virtual environment to be able to import all of PyHC's packages and for people to be able to use them, because it's been a comically large problem just not being able to use one PyHC package when you already have an environment because, software dependencies or whatever are a thing. But at the moment, the best way I have to share that is to make a Docker image and stick it in Docker Hub. And then it relies on people to know how to use Docker and pull it in. So being able to just stick it in front of people in a place where you say, go to a URL and just spin up Jupyter Lab or whatever it was and use it would be the dream. So first, I guess just first comments, congratulations for getting that far. And I guess maybe to stick with my most maybe important question first, and we might circle back around to me, is well, maybe I'll start with cost to be boring. Just make sure I caught your slide. There was a $4,500 figure. Was that actually what your org paid to spin up the thing, or was that the theoretical what it would have cost somebody to spin it up themselves?
It's both. 2I2C is having to, they're having to figure out a different cost model based on new technology that is coming out, which I can speak to really quickly. I talked about it briefly. But so originally it was, I think, $2,250 to start the hub. Like the first month, or the initial startup is $2,250, and then it was $2,250 per month to keep it like maintained. So just for 1 month, you end up paying both costs, whereas to keep going each month is $2,250 on top of that. So yeah, that's the initial cost that they don't end up having to pay for that 1 month. I alluded to it, and yeah, we've been, so right now we have that other tag that I mentioned where you can like add your own Docker image to CryoCloud, whereas a couple months ago that wasn't possible, right? They hadn't built the infrastructure. No one had created the infrastructure to be able to do that. So before a couple months ago, CryoCloud really mostly served geoscientists, probably mostly cryosphere scientists, because the environment that we had available was tailored to a cryosphere scientists like environment. And I mean, there's the ability to build your own environment inside CryoCloud and adjust it, but that takes a lot of time, and you have to have some expertise for that. So now you can add your own Docker image. You just have to know where to find that Docker image, right? To get that tag, which is not ideal. It's way better than it was, but not ideal. So for instance, for our GeoSmart Hack Week, it's a machine learning Hack Week. And so they were accessing a Pangeo image for that Hack Week, which worked out really nice for them. But now, so they haven't released this yet. I'm not sure if you're aware, but they are now building a tool to be able to construct a Docker image from a requirements.txt. So now, as long as you know what your environment is, and like what software you want, you actually don't even have to have the expertise to build your own Docker image. You can have that built from scratch. And so what this does is, part of the question that we're trying to answer with CryoCloud is, what is the boundaries of a community? Like, who belongs in CryoCloud? How big should that be? Should it be, machine learning specialists and like modelers should be in a different hub? Like, what is the boundaries? And like, once you start being able to add your own Docker image, especially to construct your own, like, why wouldn't you guys be able to be on CryoCloud with us just as easily as, anyone from our community? And so it starts breaking down this boundary of what we assumed might be our community. And like, why can't NASA just build, one Jupyter hub and allow everyone to access it now? Well, that changes the pricing structure for 2I2C, because now they potentially don't have to build more than a few Jupyter hubs for the scientific community, and they have to get their money and support themselves. If they're supporting thousands of scientists on one Jupyter hub, they now have to have a different pricing structure. So that pricing structure will definitely change soon, and I think it'll depend on how many users there are in one hub. But yeah, that's an interesting question that we're trying to test now. Like, I'm trying to bring a few users from the heliophysics community into CryoCloud just to prove that we can, all work together in that space, even though we're in entirely different communities.
I
Yeah.
volunteer if you need a user. So Tasha, I'm one of the developers on Helio Cloud, which is trying to build the same thing, but for
Mhm.
Helio. And we've been talking with Jim of 2i2c, but right now we do the AWS stuff ourselves. And we're having the same issues with costing and guardrails to figure out. So yeah, I'd
Cool.
love to talk about how you're going through those issues.
Yeah. And like one thing that I'm working with 2i2c about is figuring out how we can transfer, what we've learned from CryoCloud and whatever hubs and share that a lot more easily. So I think that's kind of the next step. And yeah, I'd love to chat more if you want to use CryoCloud and check out the infrastructure and whatever, like I'm definitely happy to.
I'll email you about this then, yeah.
Yeah.
Yeah,
Leslie,
it might make sense to have a more extended dialogue with the Helio Cloud folks. I'll just throw that in real quick.
Mm-hmm.
I feel like there's some cool collaboration effort that could happen, stronger together kind of thing.
Yeah. And I mean, the bugs that we fix in our Jupyter hub, like there should be a template up there, like 2i2c is working on this, but a template out there for, what a Jupyter hub looks like and all the menu items that can go into it. But like, if we fix a bug, there should be no reason why that shouldn't propagate or at least be like communicated to other hubs and shared so that nobody else has to go through the same, process as we did to fix something, especially some of these stupid little things that like, are problematic for memory or for opening up things in the virtual desktop or whatever it is. And like those things, hopefully we can just get propagated. And there just isn't like a great way of doing that yet, but that's part of the like social model that's being built, hopefully.
Leslie, I see you have your hand up.
Yeah, so I was part of a project that was called in Geo a couple of years ago that I don't know how many people, I assume, do people in this community knows about this? Okay. So this sounds basically like this was a very early attempt to probably do something very similar in the geospace community, where we were based on Docker. We were trying to come up with some kind of homespun cloud-based solution that would allow people to access for specifically the geospace or the ionospheric research community, both data and Python packages, and kind of make it a lot easier to get started with this kind of stuff. So that project, it was one of these EarthCube projects. It ended so it ran from 2017 to 2020, and we unfortunately haven't been able to get further funding for it. But it does feel like since then, I've seen a lot of these kinds of things pop up that feel very similar in that, and I kind of I wish there were a better way. I feel like we have not been very effective at sharing what we learned from that project. And so what you're doing is far more advanced than where we ever got, but a lot of these problems sound very similar. And yeah, if there's any way I can provide some of the kind of lessons learned and what our challenges is, that would be great. So specifically,
Yeah, I'd love to.
yeah, one of the things I wanted to ask about, and you were talking about this actually, was this idea of modifying your environment. Wherein how do you, that was something we found was like critical for users to do. There was no way it was fictitious to believe we could provide an environment that had all the packages everyone wanted. So if you have a good way to do that's awesome. And then the other thing we ran into fairly quickly that I don't know whether it's not a problem for your community is the people at least the people who we were working with are insanely data hungry and insanely compute power hungry. So we kind of came up with this cool system where you could do these basic analysis, but you showed it to the modelers and it was useless for them because they couldn't run their having models on it. And then, so I don't know, it's very exciting to hear what you're doing. And if, you have this available for people to try. I might be sending you an email about how I might be able to use it for some things, if that's all right.
Yeah,
Yeah.
so we'll have to talk a little bit more about that because I've been warned that we have to like keep it very small in terms of the non-cryosphere people that
Okay.
we bring on, but we can have a conversation like it. We really need to test, like have data test this, idea of people other than cryosphere researchers being able to work on the same cloud. And so I can bring on a few people to do that. And so,
Okay,
so yeah,
if you'd like, I can send you an email of here's some things I could see myself using this for, and you can let me know whether or not any of those are a use case you would like to get some feedback on. No,
yeah.
I actually, I completely understand the need to manage your
Yeah, and like
resources.
now we realize that this can like expand infinitely. So I'm using a lot of resources from 2I2C because we're building and we're finding the gaps and we're yeah, this is like the test case that will like allow them to serve other people better. So yeah, I just have to like be cognizant of not bringing on an entire new community. But yeah, they have given me permission to bring on a few people, so we can just have, a good. It makes sense to bring other people on. Yeah, in terms of the building your own environment or adding to your environment, we have a document in our Jupyter book that talks about like how you can build your own kernel with an updated environment that is persistent. So that's the other way that we get around this. If people don't use a different Docker image, they can build a separate kernel that they can then open up as their environment. So it's nice working with 2I2C because, they're the leaders. They're like the people designing Jupyter and the leading experts in all of this. So I can ping them a lot of times to, figure out how to best use these tools in ways that, only the experts kind of understand. So that's been really nice working with them.
That's awesome. Thank you.
Mhm.
I was just gonna say real quick, and I just shoved it in the chat, but I mean, I think Leslie, what you did, you didn't have the 2I2C piece, so you were building that yourself as well. So here it's, it's really the right layering of, okay, there's this infrastructure, and then what people add on top of it is domain specific. So.
And 2I2C really works to make their stuff, transferable to anybody else wanting to whatever. If you want to take the infrastructure elsewhere and do it yourself, you can do that because it's open and it should be vendor agnostic. There's no vendor lock-in, that sort of thing. So it's been really nice working on that with them.
Yeah, the funding model is, I mean, because right now it's being paid for off of the grant money that you have to get this going. And so that's always the question for all these kinds of projects. And, the data that you have is already on the cloud because in earth science and a lot of these places, they've already shoved it there. And so is that true or no? You're shaking your head. So
some of it is.
okay.
Eventually it'll all be there. Well,
That's
not
part of
all
what
of it, but I mean, for NASA, sure. We're working on, I mean, that's one of the conversations I've had already is, working with say the Arctic Data Center, which is NSF funded, and like how do we access their data that may or may not be in the cloud? Some of their data is and some of their data isn't, and are there tools we can build to more easily access that and search it from the cloud? And yeah, one of the biggest, so that I didn't mention this, the two biggest problems that we are having right now with CryoCloud is data not being in the cloud or cloud optimized, right? You can access data that isn't necessarily in the cloud, but it's hit or miss. And also the cloud optimized data formats. So NASA is putting a bunch of data into the cloud right now in zip files, right? Like they didn't change anything, and you can't open zip files in Xarray or any of the like new, like any of the infrastructure that we generally use in computing. So you still have to download it, which is not ideal. So we're working with the data centers to really push forward this idea that we do not make new data in non-cloud optimized formats, or at least not like, as long as it's NetCDF or one of the cloud optimized formats, we're gonna like be great. But if it isn't in those formats, don't create any new data that's in this.
You mean don't add any new data to the cloud where we have to pay for it in the cloud, and then we also have to pay for egress? Or are you saying on new projects that are new science projects, don't start creating things in old formats?
New projects. Cause like, I mean, they have, for us, I mean, NISAR is a new satellite going into space. It's going to create petabytes of data, and they're putting it in HDF5 format that is really hard to optimize. It can be optimized.
Can be, right? I mean,
It can be. It needs a lot of extra work to be able to do it. And at least you can open it right into Xarray, whereas, I mean, zip files are impossible to open without downloading. So it really makes no sense to have them in the cloud. And, you know, some people are still building data sets like that. So, trying to push this narrative forward that we can't use, you know, decades. HDF5 formats are what, 2 decades old or something like that. I forget what it is, but
so is NetCDF, and NetCDF in fact is a subset of HDF5 now, right? So it's,
yeah, but NetCDF is very easily optimized because of its format, whereas HDF5 you have to do each data set individually. So NetCDF you can just use Kerchunk and it's optimized. Whereas HDF5 you have to build basically a Kerchunk
sidecar.
Yeah. So yeah, there's much better answers out there for both for all of this. So that's kind of something we're working with the data centers on. But so that prevents our users from being able to access data. That's a big problem. That's a boundary for users to use CryoCloud, is the fact that, you know, a lot of their data sets aren't as easily accessible as they need to be.
So if I have a comment about that as well from our previous experiences. That was a huge problem we had. Although with the NSF community we were working with, there was a huge amount of disorganization. Historically, it's a larger problem of, and this would, like, people who had HDF5 files were well behaved. But yeah, having users who have data not available and they want to use their data that is not on the cloud, it's on their server, and how do they add it to their system was something that was a very challenging issue to deal with.
Yeah. Yeah, and as you guys were mentioning, you know, the cost issue, you know, the boundary you guys also ran into is being able to sustain the ecosystem and pay for it. And so, like, the nice thing about working with 2I2C, at least at the moment, is that it's very cost effective to work with them. They make this as cheap as possible. I didn't show slides, but they're running this cloud infrastructure for education at Berkeley. They're running it for classes that are like 50 to 2,000 students for $1 to $2 per student per semester. And And so the infrastructure that, you know, they're building is super cost effective. It doesn't really cost a ton of money for me to keep CrowdCloud running. And what's nice is now that I'm bringing like a lot of these events online into CryoCloud, like the Hack Weeks, they're, you know, part of this. The East Science Institute does these Hack Weeks. They're very much bought into this open science model. And so when they use our resources, they're happy to provide, you know, money for cloud credits and supporting CryoCloud. So it becomes much more self-sustaining that, you know, these groups bring in are happy to contribute money to keep this ecosystem kind of working. So that helps to relieve the burden of really needing, you know, all of our funding agencies to do that. But I mean, honestly, it's pretty cheap to keep CrowdCloud running. It's, you know, we're using right now $12,000 in cloud credits a year. And then it's whatever, I think like $2,500 a month calculates out to.
So is the intent ultimately then to just have some cryosphere community support for that permanently? That, okay, we're just going to leave this going. Once the grant ends, the funding agency will pick this up, or a blend of them, and we'll just be able to leave it up and somebody will manage that, or there'll be a rotating management, different institutions, or because what we've done on HelioCloud is we'll create the infrastructure and an institution can stand it up, but then, you know, they have to pay. And it's up to them to decide how many instances they want, because like you say, per instance, there's overhead kind of costs, and then the per project costs are low. But, you know, we've decided, well, long-term, a project would have to pay for it themselves, or an institution, and then they need to stand up the infrastructure as part of their own IT, you know, support. So institutions of a certain size can do that. But, you know, a small institution or a small project might not be able to.
Yeah, and I think that's the beauty of CrowdCloud is not every institution or group needs to do this, right? Like I have 300 users right now, and in our opinion, NASA should be providing this as a service to its scientists. And so potentially you just have one hub for NASA, and any scientists working with NASA or collaborators can end up using it. There's a lot of like security hurdles to jump over and things like that that would have to be figured out, but that's like the pie in the sky like idea for
One at
CrowdCloud.
NASA for all of cryosphere, or one at NASA for everybody NASA. Those are very different, right?
For everybody, right? Because now that we have this ability to add our own Docker image, like why wouldn't a heliophysicist be able to use the same hub as a cryosphere researcher? It basically means like our communities don't have to be siloed anymore. We can all work literally on the same one. It's just like having the Docker image to add to it, which we now can't have the capability to do. So the new advancements that we have in the last few months, I think, makes it very possible for NASA to build one Jupyter hub and provide it to all of its scientists. There should be, I mean, as I mentioned, like each institution should not need to have experts to build all of this infrastructure. It's a fucking pain in the ass. Like it was terrible for me to learn how to build CryoCloud. No other scientist like should need to do that, as you know, to get our science done. It's really nice to have 2I2C providing that. And as much as we can share resources and expertise, we should. And I think with these new capabilities, we can share it almost infinitely. But yeah, I had something else I was going to say now. I forgot.
What would be the biggest like blocker in making that happen and getting one Jupyter hub for all of NASA? One Jupyter hub.
NASA has security requirements that they are well aware of our roadblocks to open science. And so you have to have certain like credentials to log into their infrastructure and things like that. And that ends up like preventing people from being able to use it who should be able who we really want to be able to use it. So potentially you have maybe a NASA and a non-NASA one. I'm not sure. The beauty of CryoCloud is you don't have to have NASA credentials and like all the security requirements and whatnot to be able to access it, but NASA can still use it. So security is one of the biggest hurdles, I think, for NASA building something like this. Yeah, I
And
think
also just the bureaucracy and the infrastructure. I mean, one thing across all of NASA could get pretty unwieldy as everybody wants their piece of it or priorities, or it might make sense to do it per science division, or I don't
yeah,
know.
it could make sense to do that. The nice thing about CryoCloud or having like one is that everyone's building in the same one instead of building a bunch of different ones. But I mean, if
I mean, the
there's
infrastructure should be the same.
yeah, the infrastructure should be the same. There should be communication between. We're running, so we've worked with where we thought about working with SMCE, which if you guys aren't aware is like
Oh, no,
the
yeah, that's who we're
That's
working.
who's funding us for Helio Cloud.
okay. So we ran into issues with SMCE because they haven't shared any of their infrastructure. Like the progress that they've made in terms of, you know, being able to work with security in Jupiter hubs and the security needs of NASA and things like that, that hasn't been shared back to the community. And the hierarchy of like who gets preference in terms of like if you have a bug or if you have a problem or if you have a need, there's a hierarchy in terms of who gets who gets help first. And that was an issue with us for us because that's not open science. And so we're working with NASA to like have more conversations about how we jump through those hurdles, because obviously those aren't purposeful. A lot of that has to do with, you know, security requirements from NASA and things like that, that they don't have any control over. But I believe also the IT guys running SMCE are also for profit. So I have no idea how much they actually get paid in the background, but I would imagine it's more than what we pay for 2I2C. That isn't transparent. That's also part of the issue is there's the pricing structures aren't transparent there.
That's
So
true. I
there's
slightly
like
misspoke. We're funded by the heliophysics division, and then NASA has their Helio Cloud environment up under SMCE with their requirements. But all the Helio Cloud infrastructure is also released as open source, so anyone can put it up. So it kind of fits that 2I2C right to replicate.
yeah,
So that goes
that's
more to the
cool.
private cloud, like anyone can put up a Helio Cloud and let anyone on board that happens to be authorized by
Right,
them,
so
rather than following the NASA requirements.
Cool. So you guys are kind of sitting in a different realm than I think SMC was when we chatted with them.
Mhm.
That's a really cool space to be in, I think.
well, the
So
NASA
it
person,
still does run the NASA Helio Cloud instance, but that's only for NASA affiliated people. They have to do the NASA onboarding that you were talking about.
Okay.
And generally they're limited because they're covering the cost for the NASA people rather than flowing it through. So there's some, I think, usage limits there. Potentially.
Yeah. And figuring out like who should be allowed on these clouds is really tough, right? Because if we want to like democratize science and, you know, kind of reduce these boundaries, we want to be able to, you know, have collaborators who are outside of NASA, who are, you know, international.
Researcher in the field is a big.
Yeah.
well,
So
that's,
it's a really interesting question. These are like so cool. A lot of these questions that we all like are kind of running up against.
yeah, and that's, oh, Becca's got her hand, I could defer.
Should wrap up with
Well-
Rebecca's question, but we are at the top.
Let's see, we're out of time. Is there time for my question?
Go ahead and ask the question and then we'll
Okay.
wrap.
All right, thanks. So I think we're seeing part of the answer with some test things that we're seeing out of Earth Science with this beta, where they have, you can go to a given landing page of a data set and you click a button and you get launched into this Jupyter Lab thing with a notebook in front of you, where you can start doing some beginning post analysis on the cloud. And you don't have to log in and do anything, but it's not persistent. It won't stay. You're limited to some sort of computational power out there. And then you can download your greatly reduced data set that you've produced and your script that you used to do it and move on offline. No logins, just limitations on how long it's going to persist and how much you can do on there without logging in.
And you said that was through what?
Veda, so VEDA.
Oh, Veda.
Yeah, you should, you know that? You know about that
Yeah,
one?
so 2I2C is running Veda, I think.
Yep. Not for free.
No. Yeah, I mean, these new models, like all these models that we're testing are going to be, it's really going to be really fascinating to see like what works best, right? And a lot of even just working in CryoCloud, your workflow ends up being completely different than it would be on your personal computer because the data storage model needs to be very different. You don't want to store data because it costs money to store data. So we're like writing up a document of, you know, how to most efficiently work in CryoCloud, which is not to download data, not to save any of your intermediate, you know, steps or whatever it is. You run your workflow, you stream the data in, you only keep the end product. And if you need to, you migrate that end product out of the cloud immediately because it's going to cost money to store that data. So yeah, these new like models for how what the workflows are, I'm going to be really curious, you know, how well Veda sort of works versus cryo. Like there's so many different options out there, right? And we're just like needing to really evaluate which ones are most effective. So it's kind of exciting, but it's also a pain, right? Because who knows right now?
I have to drop. It's been fun though.
Good to see you.
Yes. Yeah, let's go ahead and wrap up since we're at the top of the hour. But thanks again, Tasha, for coming on and crowd clap with us. There's certainly a lot of lessons learned on your end that we can benefit from. And
Yeah, happy to chat more for sure.
yeah, I hope
Yeah, that was kind of my question. The HelioCloud folks, I think, could benefit from further.
Yeah, and
Yeah.
I'd love to learn more
Question.
about HelioCloud.
Okay, yeah, so that's
We'll
great
have
too.
an email in like 5 minutes that can
Okay.
work it further.
Sounds great.
awesome.
Excellent.
Well, that's all we've got for today. We're at the top of the hour. We'll have another Telecon in 2 weeks' time. John Niehoff was gonna lead a discussion on meeting overload and what we want to do about that.
Sweet.
So meeting on
meeting
meeting overload, I'll be there.